I hope you all are fine and doing well. So I welcome you all in the next video tutorial of Pharmacognosy and Phytochemistry 2, that is BP 504T. And we have completed unit number 4, that is the industrial production, estimation and utilization of the phytoconstituents. And in this video tutorial, we are going to cover yet another important phytoconstituent, that is atropine. So let's start. So I hope you have remembered this plant because we have completed this plant several times. So atropine basically is obtained from different plants like Atropa belladonna, Datura stramonium and Hyoscyamus niger. So these are three different plants and these all contain atropine as a major phytoconstituent in it. So this is your Atropa belladonna. This one is a Datura stramonium. And yes, this is Hyoscyamus niger. And these all belong to the family of Solanaceae. Atropa belladonna, Datura stramonium, Hyoscyamus niger, they all contain atropine and they belong to the same family, that is Solanaceae. So if we talk about its industrial production, so take an example of a plant. Suppose we have used this as a belladonna leaves. So first of all, plant material is taken, like if say in this case we have taken belladonna plant. Okay, so first of all we have to dry it, coarsely powder the belladonna leaves, and it is extracted with the alcohol that is 95% in the Soxhlet apparatus. Yes, that is known as the hot percolation or continuous hot extraction. So I hope you remember about the Soxhlet extraction. Yes, we will pack the drug over here. So main component of the Soxhlet extraction unit includes, this is a side tube, this is a siphon tube, where you will put solvent over here in the RBF. So when the boiling point of the solvent will rise, it will rise through the side tube, and here is the condenser is attached. Again, the vapors will convert it into the liquid state because over here condenser is attached. Okay, then these liquid droplets will fall down into the drug and your extraction procedure start, means penetration of the solvent inside the drug, solubilization of the active portion, then escape out. Then over here is the siphon tube. So this will gradually slowly filled, and when the solvent will appear at this point, then due to gravity it falls down back into the RBF. That's why this method is known as continuous hot extraction or Soxhlation or Soxhlet extraction. So after the extraction, what we have to do, we will collect the ethanolic extract because we have used here as a alcohol, ethanol as a solvent. Then we will concentrate it, and finally what we will do, we will dissolve it in HCl and then filter. I hope you remember about the addition of acid and base in the alkylated drug because we have already completed this point. Okay, so you will concentrate it and then you will finally add HCl and then filter. And that filtrate contains alkaloids in the aqueous solution and is extracted with PET ether. So what will happen? First of all, you will take, first of all, drug is taken, extracted with alcohol, concentrate it, then you will obtain a mass and extract, we can say here, syrupy mass, then you will add an HCl. So what will happen? It will form a salt formation. As we know, this atropine over here we have used leaf. So this drug is a mixture of different type of plant pigments like chlorophyll also. So we have, first of all, we have to remove that particular pigments. So what we have to do, when we add HCl over here, you can see here, it is written that filtrate contain alkaloids in aqueous solution. Yes, and then it is extracted with PET ether. Why it was extracted with petroleum ether? Yes, this is the answer. To remove the chlorophyll pigments and other impurities, we have to use a non-polar organic solvent so as to remove the impurities, because only then we will obtain a particular compound in a pure form. Okay, and then we will aqueous solution was made alkaline with ammonia. Again we will add a basic solution into it so that the alkaloid will remain free now. Then it was extracted with chloroform thrice, and finally what we have to do, we will combine all these chloroform extract and then we will remove the chloroform extract using vacuum filter, okay, or rotary evaporator, and then finally we obtain the residue, that is the crude alkaloid, It is again treated with an acid, that is oxalic acid, and then alkaloids are finally crystallized out, and with the help of fractional crystallization we will obtain atropine in its pure form. See, again, this is very simple. First of all, drug is taken, extracted with alcohol in what? In Soxhlet apparatus. Then you will collect the ethanolic extract, concentrate it, and finally what you will do, you will add an HCl, dilute HCl, which was prepared in water, and then you will filter. So what happen when you will add HCl, it will form alkaloidal salt. And yes, it is soluble in water. Over here it is written filtrate contain alkaloid in aqueous solution. So we have to remove this alkaloid from this aqueous solution, because we know alkaloids have tendency in organic solvents like chloroform. Like in case of caffeine, we have completed that caffeine is soluble in what? Chloroform. But over here, as the drug contain mixture of phytoconstituent, so we will, what we will do, we will treat this aqueous solution, and it was further extracted with PET ether. For what purpose? For remove the other impurities like chlorophyll. Okay, and then again we will use this acid base mixture. Then first of all we will make the aqueous solution alkaline with ammonia solution. At this stage the alkaloid become free. Then first we have to urgently use chloroform so as to capture, so as to trap this free alkaloid in the chloroform. So we will extract it with thrice. Then we will combine the extracts. We will concentrate it basically, and we will obtain a residue. Okay, and that residue contain crude alkaloids, and then we will treat this residue with again acid solution like oxalic acid. The alkaloids are finally crystallized out, and we will obtain atropine in this case, because we have used here belladonna plant. So I hope this is clear. This is very simple procedure for the isolation of the industrial production of the atropine. The next is identification test. We have also completed it, that in case of atropine, Vitali-Morin reaction is used, and it is in this test atropine is treated with the fuming nitric acid followed by evaporation to dryness, and with the help of methanolic chaos solution which was prepared in acetone, basically a violet coloration take place due to the presence of the tropane nucleus. So I request you to watch the previous video. I have cleared the Vitali-Morin reaction at this point, at that point. Okay, then TLC method is used for the identification. We know in TLC we need, again, it's a chromatographic technique. So yes, go for the stationary phase. So what is the stationary phase here? Yes, silica gel, but pre-coated silica gel is used. And mobile phase, toluene, ethyl acetate and diethylamine in the ratio 70:20:10. And yes, for the detection purpose, use drag and drop reagent, and the observation is done at UV 365 nanometer wavelength. Here is the representation of the atropine. Don't worry, we will do the structure in the upcoming videos. Molecular formula over here, C17H23NO3. It has a melting point of 114 to 160 degrees Celsius. Appearance of white crystalline powder. So next is the estimation of atropine. Again, we will follow simple method of the colorimetric determination. I hope you have now recalled this colorimetric determination, because we have completed this aspect also, colorimetric determination. So I acknowledge all the sources I have used, and we will do the next part, in which we will study about the estimation and the utilization part. So thank you for your patience in listening.